Alright, so welcome back. Today we're going to be finishing up with the law of sines. Now, there's something unique about the law of sines. Let me show you what I'm talking about. Today is the 29th. And this is going to be section, oh, hey. There we go. Section 6.1. It's called the law of sines. And it's called ambiguous cases. Ambiguous is just another word for special cases. Alright. Now, here's what the whole idea is about. So yesterday we focused on the first case. You did have one homework problem similar to number 2, but you should have been able to figure it out, and if not, I posted the homework solutions. If we have two sides and an angle opposite it, so a side-side angle, that's what we're going to be talking about today. This is called, we'll call it SSA. And here's something that could happen. Whenever you're given a problem like this, and let's say you're given angle A, side A, and another side, we'll just call it side B. You see how these two, we have an angle and we have a side. You have to, if you're given that, if you're given one angle and two sides, and one of those other sides is opposite of that angle, you have to use what we're going to teach you in this lesson. You want to always draw, it's just going to make your life easier. If you draw the angle right here, the side opposite it over here, and then the other side you want to put on this side right there. That's how you always want to arrange it. So let's say even if you're given side C, you want that to go there. It doesn't matter what it is. Alright? So you always want to set the problem up like this. Now the way that we figure out the height of this triangle, that's going to be our main idea. Because what could happen if you have a problem like this is you can get 0 solutions, 1 or 2. And it's all based off of what I'm going to show you. Now the height of this triangle, let's talk about where it comes from and then I'll make it a little bit easier. Now the height would just be a right angle, right? And let's say that that's, call it the height. To get that height, if this is a right angle, if we take the sine of angle A, that's going to equal the opposite side over the hypotenuse. Or, if we cross multiply, the height would equal C times the sine of A. The height is always equal to, in this scenario, it's always equal to the other side times the sine of the angle. So this is, I know Mr. Cilio teaches it differently, and I know sometimes people might find that confusing. If you do it the way I'm showing you, if you have a side-side angle like we have, side-side angle, if you draw it like I'm showing you, that's the easiest way to do it. Okay? Now what we always want to do is we always want to find the height first. Okay? So step 1, and I'm going to post the flow chart for this, and maybe that'll help you understand. Step 1 is you want to find the height of the triangle. And it's always going to be the height is going to equal the other side times the sine of the given angle. And just look at my drawing. Now from here there's 3 things that could happen, and I'll show you with examples. One thing that could happen is the height. could be bigger than the side opposite the angle, which in that case is this, the height. So let's say the height was 15 and that side was 12. Well, if we were to draw this picture accurately, we can't change this angle. That angle's set. If the height is bigger than that side, there's no way you could connect it. And this would give us 0 triangles, or we would say that there's no solution. All right. Another thing that could happen is that the height could equal the side opposite the angle. If that happens, your angle is here, your height, and that side would be equal. Well, that would be a right triangle. So we'll say a right triangle, and there's one solution. What can get a little tricky is if the height is less than the side opposite the angle. And from here, what you do is you compare the side opposite the angle with the other side. So looking at the notes, we'll use side A, side opposite the angle, and we'll use the other side. In my notes here, I have it as side C. There's two things that could happen. One thing that could happen is the angle side could be bigger than the other side. And in that case, you would have a triangle that looks like this, where side A is greater than side C. In that case, there's one triangle. One other thing that could happen is that the angle side could be smaller than the other side. And in that case, you could actually have two triangles. One solution would look like that, and one solution would look like this. Or instead of drawing A on this side, we actually draw it so it looks like this. And that's the second triangle. Now, I'm sure I'm going to have to go over that, and I will, but this would give you two triangles. All right. So if I were you, I would print out the flow chart that I posted to Classroom. I would have these notes handy. Let's take a look at some examples. I think I have 1, 2, 3, 4 examples. This lesson might go a little bit longer, so if you need to, you could always stop it and take it all in. Our first example looks like this. What if side A was 15, side B was 25, and angle A was 85 degrees? Now, we have a side and we have an angle opposite it. So, just like I advised you to do, we're going to draw angle A, the side A, and the other side is B. And that's what we have. Now the question is, do we have 0, 1, or 2 solutions? And then if we have a solution, we have to find it. First, let's find the height. Now the way that we talked about finding the height is it's going to be the other side times the sine of the angle. When I'm talking about the other side, I mean this side. Right? This is the side opposite the angle. So let's see what the height is. It's going to be 25 times the sine of 85. And for this example, 25 times the sine of 85 is 24.9. So the height is 24.9. Well, look at this side. Once you find the height, the next step is you compare these two. If this was drawn to scale, that's 24.9. 15 would be like over here. There's no way, no matter how you swing this side, that it's going to connect. So in this case, we have an example like this, where the height is greater than the side opposite the angle. And that means that there's no solution. If you tried to do law of sines here, your calculator would give you an answer that says undefined or no solution, and that's because of this. There's no way to make a triangle where the height is bigger than that side. Let's try another example. What if I told you side B was 35.3, angle B was 34 degrees, and side C was 63.1. Alright, so let's draw this the way that I told you to. I see that we have a side and an angle opposite it. This is a side-side angle scenario. So I'm going to put angle B here, 34 degrees. I'm going to put side B over here, 35.3. And the other side, side C, 63.1, I'm going to put right there. So this would have to be A. First step we do is we find the height. And the height's always the other side times the sine of the angle. In this case, it's 63.1 times the sine of 34 degrees. So 63.1 times the sine of 34 is 35.3. So that means the height is 35.3. Well, that's the same thing as this, right? We always round to the tens. So if they're the same, looking at our sheet, there's one right triangle. We can go ahead and solve that. So we have one right triangle. So in that case, realistically, it looks like this. If we have a right triangle, we could use some of our old tricks to do this. I'll just do this quickly here. So A, B, C. C would have to be 90 degrees because we established that based off of our flow chart. Angle B is 34 degrees. A, B, C. C is 63.1. So using the Pythagorean theorem, we have 180 minus 34 and 90. That's 56 degrees. And then looks like side B we know is 35.3. And then if we use Pythagorean theorems, 63.1 squared minus 35.3 squared. And the square root of that I'm getting is 53 or 52.3. So just double check that smallest side, smallest angle, largest side, largest angle. Alright, so that would be that. A couple more examples to go. And I did have an activity for us where we would be cutting out, different sides so you could see this, but, I can't see you in person, so anyway. Let's try a different one here. Number 3. Angle C was 72 degrees. Side A was 22, and side C was 21. Side angle, so I'm going to draw it like this. The angle and the side, the other side. Alright, so let's start doing this here. First thing we do is we find our height. The height is always the other side, as long as you draw it like I did, times the sine of the angle. So the height would be 22 times the sine of 72. Alright, so let's see here. 22 times the sine of 72. That comes out to 20.9. Alright, so the height is smaller than the side opposite the angle. Well, let's look at our flow chart. Right here. Okay, next step is we compare the side opposite the angle with the other side. Right here. Okay, so let's do that. 21, side opposite the angle, is smaller than the other side. 22. So there's two triangles. So let me show you what this looks like. Okay. First triangle is going to be normal. So let's just go ahead and solve this triangle, and then I'll show you what the second triangle looks like. This is not a right triangle, so we have to use the law of sines. Okay, so I'll just do this quickly here. Side C over the sine of angle C is equal to side A over the sine of angle A. If you do this and use inverse sine, we did this yesterday for the homework, or you could look at the homework review from today, but 22 times the sine of 72 divided by 21, and if we take the inverse sine of that, we get angle A is 85.1 degrees. So 85.1 plus 72, and if we subtract that from 180, we get 22.9. And then to figure out what side B is, we're going to take what we were given, 21 over the sine of 72, set that equal to side B over the sine of 22.9. And it tells us that side B is 8.6. Okay, so that's one triangle. The way we get the second triangle is we're going to keep this side exactly the same, this angle exactly the same, but instead of drawing 21 over there, we're going to draw the 21 right here. So our second triangle is going to look like this. Where we had C, A, B, 72 degrees, 22, and C was 21. Now this triangle, even though conceptually it's a little hard to see like how you get it, instead of drawing 21 over here, we're drawing 21 over here. Really, that's what it comes down to. But if you find that first triangle first, I mean, this side is really 21, right? We're just drawing this over here. And if that's an isosceles triangle, this 85.1 would actually be the same as this angle. We learned that from geometry, that if two sides are the same, their corresponding angles are the same. So if this is 85.1 degrees, that's a supplementary angle. This angle, angle A, would be 180 minus 85.1. And that comes out to 94.9. To get angle B, we could do 180 minus 94.9 and minus the 72. And we get angle B is 13.1. So then the only thing we don't know is side B. So we could take what we're given, 21 over the sine of 72, and set that equal to side B over the sine of 13.1. And if you do that, 21 times the sine of 13.1 divided by the sine of 72, side B comes out to be 5. So these are your two solutions. It's a little tricky, but if I went too fast, just try to watch what I'm doing and maybe pause it, try to take it in. All right, there's one more problem I wanted to do with you, and that'll be it today. Okay. Fourth one says, what if side B was 1006.9, angle B was 79.8 degrees, and side C was 795.1. Let's draw it out. I see a side and opposite it, so I'm going to set it up like this. C is going to go right here. So this would be A. First thing we do is we find the height. The height is always equal to the other side times the sine of the angle. So that would be, the other side is 795.1 times the sine of 79.8. And that's 782.5. So at this point, once we get the height is smaller than the side opposite the angle. So if you look at the flow chart, the next step that we do is we compare sides A and C, and actually the other side is going to be longer than the angle side. So there's going to be one triangle. I'll show you that. And then this will be the last problem. So the side opposite the angle is larger than the other side. So this gives us one triangle. So you just have to do the normal law of sines here. We'll do that quickly, and then that'll be it today. Okay, so let's do this. 1006.9 over the sine of angle B equals 795.1 over the sine of angle C. And I'm getting that angle C is equal to 51 degrees. So if we do 180 minus 51 minus 79.8, it's 49.2 degrees. And then to finish it up, 1006.9 over the sine of 79.8, and set that equal to side A over the sine of 49.2. and I'm getting side A is 774.5. All right. All right. So let's just double check. Largest angle, largest side, smallest angle, smallest side. All right. So for homework, this is what I would like you to do. I gave you actually a worksheet. So the homework, what I would like you to do is the worksheet. Please have it done by midnight. Post the answers, and we'll talk about this tomorrow. You should be okay from looking at the worksheet. Of course, if you have questions, you could always ask me, and the answers, step by step, will be posted tomorrow. Thank you very much. Have a nice day.